So welcome to Hedvig's webinar. What do your containers want to be when they grow up? My name is Chris Tedesco. I'm the Solutions Architecture Lead here at Hedvig. And along with me today is Abhijit Shenoy, Founding Engineer for Hedvig. Abhijit is the Product Development Owner for our container integration software. He's going to be providing a deeper dive into our capabilities and also demonstrating our container features. Today's webinar is in listen-only mode, so please utilize the Q&A functionality to send in any questions. We can address them at the end of the presentation. Today's presentation will consist of two main parts. First, I'll briefly discuss the adoption of containers in the enterprise, and then Abhijit will take us through Hedvig's container features as well as a demo. After that, we'll close with some Q&A and next steps. So over the past 6 years, we've been hearing a lot about containers and the impact they're making on how applications are deployed and hosted. Like other new platforms, containers caught on as an easy way to develop and test applications. From there, it's only a matter of time before new features and capabilities were developed, and that propelled the adoption of containers. Public cloud embraced containers, and the emergence of Kubernetes really helped organizations orchestrate container usage in almost any environment. DevOps groups embraced containers as part of modern infrastructure. So today, we see enterprises using containers for applications that require persistent storage across clusters and data centers. Needless to say, the future is bright for containers. Mainstream adoption is already in sight, and it'll be interesting to see how things grow from here. Next, let's look at a high-level view of a typical multi-cloud container-based infrastructure. Containers are emerging as not only part of the cloud, but within on-premise data centers as well. Enterprises are determined to embrace hybrid cloud capabilities to address age-old concerns such as availability, disaster recovery, capacity on demand, and more. Orchestrating this modern infrastructure requires tools that work across clouds and across physical locations. While persistent storage enables additional container workloads, data remains local, and this is a limiting factor. So we at Hedvig believe we've accomplished something very valuable, and that is always-on data availability across heterogeneous and geographically distributed container clusters. We call this the Holy Grail. Why is this important? Well, if you think for a moment about the key components for modern or next generation infrastructure, Hedvig's poised to deliver the features and capabilities needed, including the traditional robustness that enterprises expect. Take these new capabilities to address requirements that have emerged from hybrid and multi-cloud, and those operating models can really take off. So a little bit about what makes Hedvig different. Here's another view of a container infrastructure, but with one key difference. The introduction of a persistent storage fabric across all clouds and data centers, eliminating the persistent storage silos which are limited to each data center. So Hedvig storage is distributed, it's multi-workload capable, and it gives you that persistent storage across your entire infrastructure. The benefits of this approach include enabling the next generation capabilities that enterprises are looking for. So let's take a look at Hedvig's principles. To help understand how we're a natural fit for containers, you have to envision where we fit within your infrastructure. Hedvig was designed from the start for any infrastructure, whether it be private, hybrid, or multi-cloud. Our distributed storage platform provides the ideal storage across your infrastructure. We have synchronous data availability for different locations, regardless of where they've always been, and that's a foundational element of our design philosophy. Our purpose-built two-tier architecture allows flexibility and rapid innovation to support a variety of workloads and those of the future. So at this point, I'm going to turn it over to Abhijit, founding engineer here at Hedvig. Abhijit, here's to you.
Hey guys, thanks Chris for setting the stage. So let me present my screen here. All right, so for this part of the presentation, I'm going to talk about stateful applications and how Hedvig enables stateful applications in case of containers. Right now, Let's talk about what are stateful applications. So in a nutshell, stateful application is any service that requires backing store of some kind to keep state. Good examples of this are databases like Postgres, Cassandra, MongoDB. If the service restarts on the same host, which can happen, or if it's scheduled on a different host, the service needs to be able to access its backing storage to continue functioning. Right? So in a nutshell, that's what a stateful application is. Now, in a large organization, you can have many such stateful applications, right? And how do you manage these stateful applications in a very seamless manner? So that's where container orchestrators come into the picture, right? So to put it briefly, a container orchestrator is a software that manages a full life cycle, the full life cycle of stateful services, right? So using container orchestrators, it's very easy to deploy applications in a test only environment, but you need to consider a lot of other factors if you were to develop stateful applications in a full-fledged production environment. And some of these key attributes that you need to consider are high availability, scalability, security, error handling or failure recovery, non-disruptive upgrades, and also a container orchestrator needs to have built-in automation, right? So the container orchestrators that you see on the screen here, for example, Docker Swarm or Mesosphere DCOS, Kubernetes or OpenShift, all of these container orchestrators provide these capabilities, right, which makes it easier for application developers to actually develop stateful applications. Now, since storage is a key aspect of stateful applications, a container orchestrator coupled with a solution like Hedvig, which also is built on these principles, will make it even more easier for application developers to develop these applications. It almost makes it very easy or trivial to come up with an application that is fault tolerant and at the same time maintaining its state across restarts. Now, this is also the reason why Hedvig integrates very easily with a variety of different container orchestrators. So let's look at a few integration examples. The first example that I'm going to go over is Kubernetes, right? So on your screen here, you can see that we have a Kubernetes cluster which has 3 master nodes and 3 Kubernetes worker nodes. Kubernetes worker nodes are the ones that actually run your stateful applications, right? Each Kubernetes worker node deploys, inside each Kubernetes worker node, we deploy a component called as a storage proxy, which is nothing but a lightweight component which northbound talks your storage protocol, in this case iSCSI, and southbound converts that to the Hedvig protocol, and that determines how the data is spread out in your underlying Hedvig cluster. Now, another component that is also installed in case of a Kubernetes integration is Dynamic Provisioner, whose sole purpose is just to dynamically provision volumes when needed. Now, the underlying Hedvig cluster itself can span across, can reside in a single site, or it can span across multiple sites, or it could even be a hybrid cloud cluster where it spans across your on-prem as well as cloud sites, right? And in a demo, I'll talk more about how we have actually set this up to show you guys certain capabilities that we provide. So this is how Hedvig integrates with Kubernetes, and the integration with OpenShift is pretty similar as well. Now, let's talk about a different example in case of Mesosphere DCOS. Now, irrespective of which container orchestrator you use, the overall integration will pretty much be the same. We have one storage proxy which is running per host or per container engine, which is responsible for all the IOs on applications that are running on the same host, right? The only difference in the Mesosphere DCOS integration is the Docker volume driver, which will be used as the dynamic provisioner to provision the volumes. Now, I have set up an environment to show you guys some of the unique capabilities or unique features that we provide or we bring into the table in case of containers. So this is what the demo setup looks like. So for the demo, I have set up a 9-node cluster. We have 3 nodes here running on-prem. We have 3 nodes running in AWS in US West 2, and we have 3 nodes running in Google Cloud, again in US West 2. I have 2 Kubernetes clusters set up. So the first Kubernetes cluster is running on-prem, which has 3 worker nodes. And as you guys can see that it has 3 storage proxies as well, 1 per worker node. Similarly, I have another Kubernetes. This is a completely different Kubernetes cluster, which is set up inside Google Cloud, which again is similar to the one on-prem, which has 3 worker nodes and Hedvig components installed on the Kubernetes worker nodes. Now, both these Kubernetes clusters can provision storage out of the same underlying Hedvig cluster. So the policies that you associate with the storage that you're provisioning will determine where the data is placed. For example, if you're developing an application which is only going to run on-prem, you can choose a policy such that its data only resides on-prem. It's never replicated to the clouds. Whereas if you develop an application which needs to be fault tolerant across site failures, for example, if you want an application that is resilient to, let's say, AWS going down completely or GCP going down completely, you create a policy such that the data is synchronously replicated across all the sites, so that even if one of the sites is completely down, your application can still continue to function seamlessly. So having set the stage, let me jump into my Hedvig cluster and show you guys what this looks like. So if you recall, we had 3 sites. The first site was on-prem. So this is my on-prem site, as you guys can see, and it has 3 nodes. This is my GCP site, which again has 3 nodes. And this is my AWS site, which has 3 nodes. So a total of 9 nodes managing about 11 terabytes of its total capacity is about 11 terabytes. Now, as if you guys can recall, I said that there is one Kubernetes cluster which is running on-prem, and you guys can see that these are the 3 nodes. Since there is one storage proxy running per node, you'll see 3 storage proxies here. And similarly, since there is one Kubernetes cluster running in Google Cloud, you see 3 more nodes here. These are your storage proxies. I'm using Rancher to manage my Kubernetes clusters. So let me quickly show you one of the Kubernetes clusters and then jump into the demo where I can create some applications. So this is the Kubernetes cluster that is running in Google Cloud. As you guys can see, it has 3 nodes and a master node. And similarly, we have another cluster running on-prem, again, 3 nodes and a master node, right? So having said that, I'm going to switch over to my terminal so that I can completely drive the demo using kubectl command, so that you guys can see that everything is driven from the Kubernetes space itself, and you don't really have to come to the Hedvig cluster to do anything at all, since we are completely integrated into Kubernetes. So before we provision or before we create a stateful application, the first thing that you need to create in Kubernetes is something called as a storage class. Think of a storage class as a template for creating your for provisioning your volumes, right? What are the attributes that you want to associate with the volume? You specify that in your storage class. So if I go to my GCP cluster here and go to storage classes, I can see that there are 3 storage classes that are present. So I've created this before we started the presentation. So the default storage class has no attributes associated with it. All it says is backend type is Hedvig block, right? Now, you typically wouldn't want to use that in a production scenario because you want your application to be fault tolerant. So the way you can do that is you create a storage class called SC Hedvig DC aware. That's the name that I've given to the storage class. And if you look at this, the policies are replication policy is set as data center aware, and the data center names are SNC1, which is on-prem, GCP, as well as US West 2, which is AWS. So what this means is if you provision a volume using this particular storage class, its data will be synchronously replicated to all these 3 sites, which means your application can run anywhere and still have access to its data. And I have also created another storage class just to show you guys some of the other capabilities that we can also provide. This is a storage class which is similar to DC aware. The only difference is that in this particular case, I also have compression enabled, which means any data that you write to a volume provisioned using this storage class will also have compression enabled. So if you want to turn on other capabilities like deduplication and encryption, everything can be done at a storage class level, and we will ensure that any volumes provisioned using that storage class will have those features turned on the Hedvig side. Let's go ahead and create an application right now. So I have a template here for creating a simple application with CentOS as my container. So I'm creating two different things here. The first section of this particular configuration file shows that I am creating a persistent volume claim using a storage class which is SC Hedvig DC aware compressed, which means my underlying Hedvig volume will have data center aware as the replication policy and compression enabled. And I'm creating a simple application container with CentOS as the image, and I'm going to mount the volume that I created earlier on under /data inside the container. So let's go ahead and create this. So if you guys can see, I'm creating this completely using kubectl command. So all I have to do is kubectl, give the config file as my GCP cluster config, and create the application. And now if we switch back to the Rancher UI, I will see that my application will be starting up. So if you guys can see here, the application is just starting up. It should just take a few more seconds for the container to come up. And while the container comes up, I also have another application here which I've already set up called as Postgres. So this is my Postgres database container. So let me show you guys this particular application while we wait for the CentOS container to come up. And so the main goal of creating this Postgres container is so that I can show you guys a unique capability that we can provide, which is migrating your applications from one Kubernetes cluster to another without migration of data of any sort, right? Because the data is residing in the same underlying Hedvig cluster. So that gives us the capability of being able to move your applications without having to migrate data at all, which means irrespective of the size of the data, you could have 100 gigabytes of data or even a terabyte of data or tens of terabytes of data. You can still move your applications container almost instantaneously and restart it on a different site without having to worry about the amount of data that it's actually managing. So I'm inside my Postgres container right now, and let me log into this using pSQL and show you guys the databases. So currently we have some system defined databases, and I've created two more databases here for the purposes of the demo called Demo 1 and Demo 2. And let me migrate this particular PostgreSQL container to a different Kubernetes cluster, which in this case is going to be on-prem cluster, the second cluster that I showed you guys, and then log into the container again and see if we can read the databases. So if I go back to my cluster, you can see that the CentOS container is now up. And if I go inside the container here and do a df, I can see that my 10 gig volume is available under /data. So what I can do right now is if I destroy this particular application completely, the volume will automatically, the space that was used for this particular container will automatically be reclaimed, and you get the space back in the Hedvig cluster. And if I go here and go to my virtual disk management page and click on this, and it's still in the process of deleting, but I can show you guys that since I created the container or created the persistent volume using a data center aware replication policy, you can see that the data center field reflects that, and since compression was also turned on, you can see that it reflects the percentage of compression that was achieved. So let's go ahead and migrate the PostgreSQL container right now. So I've written a simple script for migration. And if you guys, let me show you the script as well. So again, the script, all it's doing is using kubectl commands right here, 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 and so on, right? So again, just to stress upon the point that everything is still being driven from Kubernetes commands itself. So let's go ahead and kick this off. So first, it's going to destroy the PostgreSQL application in the GCP cluster. Then it's going to destroy the PostgreSQL volume, persistent volume claim. So when I created the persistent volume for this particular PostgreSQL application, I set the reclaim policy to be retain, which means even if I delete the persistent volume claim in Kubernetes, the underlying Hedvig volume will still be retained, right? Which was not the case for CentOS. CentOS was created using delete as the reclaim policy. So if I go back here right now, you can see that it's still in the process of deleting. So once the container goes away, you should be able to see that this particular volume is gone. So you can see that the PostgreSQL persistent volume claim is now gone from the GCP cluster. It's going to create the same claim in the on-prem cluster and attach it to the same underlying Hedvig volume, and then it's going to start an application. So since this is complete, let's jump back into the Rancher UI right now and go to my op cluster and go to workloads. You can see that the application is in the process of starting up. Let's wait for a few moments for this to complete. And you can see that the application is already spun up. Let's go ahead and execute the shell. And you can see that my two databases, Demo1 and Demo2, are now still available post-migration. So just to summarize, right? I showed you a couple of things in this demonstration. One, how easy it is to create stateful applications using Hedvig persistent volumes by just using Kubernetes APIs without having to come to the Hedvig cluster for anything at all. So that makes it very simple for application development. Another very important thing, or a very strong capability of ours, is the ability to spread across multiple sites or multiple clouds, which also gives us the ability to move workloads between sites without having to migrate the data at all. So that's another cool feature that I believe we can provide very easily, given the design philosophy that we have adopted when it comes to developing Hedvig. So thanks, guys. That's all I had to share. Off to you, Chris.
Thanks, Abhijit. That was great. So I'll see if I can take back over presentation-wise here. Okay, folks. So in summary, we've learned quite a few things about Hedvig today. The seamless container access to block and file, no changes to your workflows, the instant data availability across clouds, whether they be private clouds on-prem, public clouds, or some hybrid arrangement. Developers have to do no extra work really to take care of these or take advantage of these features. Advanced features like replication. We have obviously distributed storage with replication, compression, dedupe, encryption, so full featured. None of that requires any additional work to integrate. And of course, architects and infrastructure leaders with their business objectives get all the benefits of this platform as well. So we solved quite a few problems, and hopefully you'll be interested in giving a try of Hedvig and seeing how it can impact your plans for your next generation data center. So a little bit of housekeeping. We're going to be having these summer webinars throughout the next couple of months and then beyond. Won't be called summer anymore once you get out of the summer, but it's a good time here. And also some helpful resources that we're sharing out. You'll be able to download any of the items here, but of course, always reach out to us directly. My contact information is right on the first page. Happy to work with anyone or provide any information that you could use. And we've got a general contact URL at the bottom there as well. So without further ado, now's a good time to take some questions. And looks like we've got a couple of them submitted so far. Abhijit, a couple of questions. Can you hear me okay?
Yeah, go ahead.
All right, so we'll start with this one here. So the Hedvig CSI plugin, is that generally available, ready to go?
Yes, so we already have a CSI plugin developed, which makes it easier for anyone who is using, let's say, Kubernetes or Mesosphere DCOS or even Docker Swarm. So the CSI driver can be a single driver that can act as a dynamic provisioner irrespective of your container orchestrator. We already have our Hedvig CSI plugin available on the Docker Hub, and we can share the link with you if you want to try it out.
Great, yeah, that's actually Docker certified, correct?
Yes.
Yep, great. Okay, so how does Hedvig encrypt persistent volumes?
So encryption in Hedwig, we follow the bring your own key semantics, which is we can work with any KMIP compliant key management system. So irrespective of like any, as long as it's KMIP compliant, Hedwig will be able to use it to encrypt your data. Now, encryption you can use a single key to encrypt all your Hedwig volumes, or you can even use one key per Hedwig volume. So it's completely flexible, and the encryption happens the moment the data is received by the storage proxy, and it's completely encrypted on the wire until we actually store it in persistent media in the underlying storage nodes. And again, when we retrieve the data, we get the encrypted data back, and it's only decrypted at the storage proxy before handing it out to the application. So it's encrypt 360 all the way from your application to the storage and then back.
That's great, and correct me if I'm wrong, but that's the same technology we use regardless of the use case for Hedvig, right? So beyond containers with our block capabilities, file and object as well?
Yes, so since everything in Hedvig is a virtual disk, the encryption that I just described applies to a virtual disk, irrespective of what use case or what storage protocol you're using.
Excellent. Actually, some questions about those virtual disks. So here's one here. Are the Kubernetes persistent volumes thinly provisioned?
Yes, they are. Everything in Hedvig is thinly provisioned. We only allocate as much storage as you actually use. So even if you create a 1 terabyte virtual disk or a Hedvig volume and just use, let's say, 1 GB on disk, you will just see 1 GB of storage used.
Very nice. One more here. So can I snapshot and archive persistent volumes?
Yes. So let me answer that question in a slightly broader sense. So you can snapshot and archive and even clone any Hedvig volume, be it a Hedvig volume that is used for, let's say, persistent volumes or inside Kubernetes, or be it a Hedvig volume that is used for running, let's say, a virtual machine inside VMware or KVM.
Great. Well, looks like that's about all we have for questions. See if anybody else wants to drop a few in before we're out of time. Here's a good one. So why is Hedvig a better approach than leveraging storage arrays? So that's a great high level question. Abhijit, I'll welcome you to take that. I'm always happy to take a question or two myself.
Sure. Do you want to take that?
Oh yeah, absolutely. And I think it really does it's a great question because it addresses the bulk of what we talked about today, which is that traditional storage arrays aren't really designed for the modern infrastructure that enterprises are putting in place today. So things like containers are really a game changer. The way that virtualization changed the data center, almost 20 years ago, containers are going to have a similar impact, at least in my humble opinion. So what we're seeing is that organizations have been fighting hard for things like disaster recovery and replication, and that was always hard enough. And when we started to introduce the concept of hybrid cloud, where public cloud became for real and was absolutely here to stay, but organizations still had existing investments for their private deployments or their on-prem infrastructure. Bringing those two things together is just a really wonderful way of putting together technology that you've already spent money on, but also being forward-looking and taking advantage of the efficiency and the elasticity of cloud to keep up with those business objectives. So it's pretty easy to explain that putting a box on-prem doesn't really work when you start to get into hybrid and multi-cloud arrangements. So that's where the concept of our storage fabric offers all sorts of benefits, and it's essentially much easier to manage storage across your entire global virtual data center. That's my opinion. Do you want to add anything to that, Abhijit?
No, I think you covered all the points there.
Great. All right. Well, I think that that just about does it. We are out of questions and nearly out of time. So I want to say thanks to everybody for joining, and we'll have a recording of this available. So keep an eye out for GoToWebinar emails for all the follow-up information. And we look forward to seeing you at our next webinar, which we will announce right on the homepage for hedvig.io. Thanks again, and enjoy the rest of your week.